So my talk is gonna, I can't move that off the screen. Okay, that's lovely. All right. So mine's gonna go in two parts. First, I'm gonna just go through, and my cat has joined me, so he may just weigh in here. The first part is really just going to be talking a lot about what's going on with Swordfish and also how a lot of this stuff weighs in what's going on with storage and storage fabric management is going to be quite a bit of the focus here. And then I'm going to transition into some demos. So we've allocated a little bit extra time here over some of the other presentations because we wanted to. We did this last year as well. We spent some time on some demos, and we lumped these together today. Let's see. I swear, the minute I started talking, the cat just decided he's going to come in and chat as well. All right. So one of the things we do in the storage and storage fabric management portion and instrumentation here in standardization of manageability is, and the focus in SNIA is focused really heavily on NVMe, partnering with our partner with the NVM Express organization and developing standards-based management for NVMe and NVMe-oF Fabrics. And the reason we do that is it allows that organization to focus on the functionality themselves. So they could focus on the device and kind of the in-the-box level API, so NVMe, and we can focus on that standardization of the user level experience in the enterprise. So we partner very well there. So as Mike had mentioned, and I think Phil had also mentioned a little bit in his discussions, there's DMTF, there's OFA, there's others all working in this space. We kind of focus on the niche in SNIA around the storage specific aspects, but we're not the only ones that play in that space. NVM Express also plays in that space. So we partner and we focus on the manageability and the data center aspects of that. So that's kind of the piece that we play in there. Today, I'm just going to focus on those pieces of the functionality. And we're going to talk a lot here also as well about some of the new pieces that we're doing there. And if you'll give me just a sec here, we'll focus on some of the new functionality we have coming out now as well, which includes where we're adding some new capabilities, expanding around NVMe and the NVMe 2.0, some new work around storage fabrics, as well as extending into composable infrastructure. We'll also talk a little bit about some of the new use cases around supporting those. So, the positioning here again, DMTF covers that base. I'll go a little through background and how all this stuff is structured here before we jump into more of the specifics of those newer use cases and how all of this stuff works. And then we'll jump into the demos a little bit more. So DMTF Redfish covers a lot of the basics of server, data center, and fabric management, and then Swordfish extends all of that into the storage management. These storage management pieces, I don't know how much you guys are picking up on that. I have a lot of construction going in the house, and my contractors just picked up again, and so there's a lot of loud banging here. Hopefully, my speakerphone is suppressing all of that for you.
I am not hearing a thing personally.
Okay, so so where Swordfish again focuses, it's actually really broad, and we will be just today talking about restricting and focusing on the NVMe pieces in the NVM and the storage fabric management, but feel free to ask questions about any of the rest of this as well. But we do cover block, file, and object. We also do expect to expand beyond that as well to computational storage. When we talk about object store, that includes, functionality, key value, other capabilities which cross both into functionality that's coming in NVMe, as well as other types of object store. So when we talk about the scope here, it's actually fairly broad. So Swordfish then, covers not just traditional, SAN type of storage domain, but we broaden that out to include converged environments. So Redfish covers that traditional direct attach storage and that very simple attach, and then Swordfish covers everything past that. We also have a model to cover utilize class of service, and we partner with some organizations like the SOTA Foundation, who are looking at service-based management and provisioning and capabilities like that. SOTA Foundation is a Linux Foundation project that does QoS-based management, and it's entirely open source if folks are interested in looking at anything in that space. So what's going on? Well, we've talked about what we're going to talk about, so let's jump into that a little bit. 1.2.5 for Swordfish releases this week, includes several new things, one of which is mapping the NVMe work into the 2.0 spec. Includes NVMe smart metrics, and then more in the fabric space, some things like the advanced discovery controller capabilities for NVMe over fabrics. So we'll talk more about that in a little bit. When we talk about what we cover for things like for NVMe and NVMe over fabrics, we have basically the whole gamut, everything from documentation, spec and schema, but we also provide use cases. We provide what we call the mapping guide, which basically tells people how to work from and map everything from the client perspective all the way over to the NVM spec. So, and then we provide mockups, which I'll show you as well. And then profiles, which allow users or clients to say, this is the detailed spec. This is the properties that you need to implement. So the spec is basically, anything possible, but the profiles are, this is the specific properties you need, you should implement. And then we also have the conformance test program that really is the, allows clients or vendors to come in and say, this is the profile, this is the vendor neutral way to specify that you are conforming to the specification, and more specifically, you have implemented this specific profile against this specific profile. Now, when we start talking about, okay, what does NVMe over fabrics mean? We have the two different models to talk about. We have how NVMe sees the world, and we have how Redfish and Swordfish see the world. And so we have this mapping, and Mike popped a variant of this up real briefly and talked through it. But I'll dig into this just a little bit more in a little bit more detail here. Because this is a really important view of the world when we start talking about how do we reconcile models between two different organizations. And we spent a lot of time on this a few years ago, but it's not a view that's to be undersold here, because this reconciliation is a really, really important thing for the way that we represent NVMe over fabrics to, to the world effectively, right? So what we wanted to do was basically say, okay, the NVMe over Fabrics model, and your illustrious host for the event, Mr. Caton, has done a whole lot of the work in developing, helping to reconcile and develop this standardized model in the NVM Express environment. However, anyone who's been working on fabrics for a long time knows that there's kind of standardized models for what fabrics are out in the world today, right? There's fabrics, how you manage fabrics for networks. There's how you manage, or for Ethernet. There's how you manage fabrics for fiber channel. There's how you manage fabrics for InfiniBand. So how do these two things go together? And so that's really what we tried to do here, was say, how do we reconcile these two pictures so that when someone who knows how to manage one of these things starts using NVMe over Fabrics, that this stuff all makes sense. And so that when, I know I'm not really explaining the picture, but that's really what we tried to do here, is say, okay, somebody comes along and they know how to manage one of these things already. How do we make it so that NVMe over Fabrics isn't yet another language for them? It's not yet, you don't have to go learn ancient Greek in order to be able to do that. That's really what we tried to pull together here. So if you know how to manage storage, today, and you've been dealing with storage already, you can now manage NVMe the same way. If you know how to manage Ethernet, you can now manage NVMe over Fabrics the same way. That's what we were able to do here by pulling these models together. The model for managing NVMe over Fabrics, the model for managing NVMe and NVMe over Fabrics, the fundamental models behind these are exactly the same as managing other types of fabrics. So this is really a key principle that we maintained pulling these together. There are differences because there's always differences. Zoning is different between Ethernet and fiber channel. That's actually going to be transparent because that's the F part of NVMe over Fabrics. So that's going to continue to stay different. However, what we've managed to do is basically come up with a converged model that's what gets presented up to the clients and up to the users. And that's the standardization. And that's what we're bringing up both in these combined models that come through in Redfish and in Swordfish and in whatever the new fish name is that we're able to bring in through the OpenFabrics management framework. So that's that converged work that we're doing here between the 3 or 4 organizations. Okay. So when we start looking at a sample NVMe over Fabrics instance, you can see this gets really convoluted very quickly, because this is a really, really simple view of an NVMe over Fabrics instance. But I wanted to kind of go through before you get to this one and say, but this is actually something you actually know a lot about, because these instances are exactly the same thing. So this isn't really as complicated as it looks. What you actually have you have a physical instance. In this case, and then you have a purely logical instance, but they're created with exactly the same objects on exactly the same model underneath them. So when you get to a view like this, it's actually very hierarchical and very easy to replicate your way around when you're doing NVMe over Fabrics, because your logical view is exactly the same as the underlying physical view. So the model itself becomes very, very easy to understand, because if you can understand the underlying physical view, and in this case, a physical view would be, I have an NVMe, a simple and in this case, maybe not so simple because this one actually has endurance description sets in it, but I have some underlying NVMe SSDs, and I want to create an NVMe over Fabrics logical exported device out of those. I want to aggregate those together and present some other, present some other namespaces out of them. The model itself is very easy to replicate because the model itself is exactly the same. So I hope that's kind of helping to understand a little bit that while this looks like a complicated picture, the model underneath it is trying to help make sure that that what we're looking at from a scalability perspective is that it's just replicating exactly the same thing. Over and over. So when this actually does get complicated, when you've got, a large number of these things, and this gets, replicated at scale, it's actually still becomes very simple to understand because it's just a hierarchy as opposed to a different model. It's just a replicated model. Okay. So a lot of what we're doing here is, in some respects, we're kind of waiting. So there's a bunch of additional storage specific capabilities that we're actually going to be, we know we're going to be adding. We're talking here a little bit about storage fabric management, but in actual point of fact, a lot of what we're doing here is just basic fabric management. So as a lot of this gets fleshed out, some of the stuff we're going to be adding next is actually storage specific fabric management. So we're looking at adding workload optimization. We've started adding a bunch of performance instrumentation, but it's a lot of very basic performance instrumentation. So we've added a lot of, in version 1 through 5, we've added a bunch of new performance metrics. So we've added volume metrics, controller metrics, drive metrics. Again, a lot of basic performance instrumentation that is a precursor to looking at how do we do workload optimization. And all of those would be manual optimization in service of eventually building and enabling automated workload optimization and eventually automated fabric management. Those are the kinds of things that the OFMF can then come in and look at how do we do that value add capabilities across a fabric. Okay, so a lot of this is just, kind of explaining the hierarchies for anyone who hasn't seen it before. These are our standard slides. I could skim right through these, but I wanted to kind of have a picture here before we jumped into some of the demos and stuff. I've got a little bit more of the use case stuff that I tagged on, but I was having a hard time figuring out where to stick it in specifically, so I got it at the end. I'll skim through these a little bit. For folks that haven't seen any of this before, the way Redfish and Swordfish are structured is there's a logical view and a physical view for everything, and this will be replicated throughout the OFMF as well. So you have a logical hierarchy here, so /redfish /v1/storage, and the fabrics are in the logical view is in /fabrics. The physical view is largely in chassis. I say largely. There's always some bleed over where things aren't as crisp as one would like. When you're talking about connectivity and you're focusing on that storage fabric view, there's really two different ways to deal with that. There's connectivity and there's access rights. fabrics, you see connectivity and access rights both reflected under fabrics. We did not have this split previously. We've moved access rights, and historically, a lot of functionality we called mapping and masking has also recently been moved up under our access rights representation. So that's new as well in 125. So here you can see connectivity exactly, you know, classic and our classic representation, switches and zones. And zones are the zone representation in Redfish. It has been collapsed. So the zones, even if you see like PCIe zoning versus Ethernet versus fiber channels, all use the zone construct, even though they mean slightly different things. They will still use zones. So zones don't necessarily, they're really technology specific, even though they've got the same name. So there's a little bit of fuzziness around this, but they largely mean what you think they mean, depending on the technology. But this is primarily the triplet for connectivity is switches, zones, and then endpoints. Endpoints are a logical representation. Ports will be connectivity off of either the switches directly or off of the connectivity that would be under the chassis, like network connectors. And then again, when you're looking at access management, you get these off of what we call connections. So you see connections and endpoints here. And so the connections, again, this is all about access rights. So setting up and defining, you know, for storage, specifically, you set up a connection to a volume. So this would be set, you know, defining read, write, access, and connectivity. And there's some slightly other, you know, some other variants of usage for memory as well. I don't have that reflected here, but for memory and for volumes, you kind of define what how you determine what the access rights are for, and that's all done again under fabrics. So that's the basics here. So when you talk about where does the OFMF plug in, it plugs in kind of down here into this interface under that connectivity. It does not generally plug in. It leaves all of the resource allocation for the systems and storage in the other branches, and it plugs primarily into the fabrics infrastructure. So that connectivity, as I noted, there's a couple 3 points, right? So we have the fabrics chassis. There's additional connectivity here in that physical space under chassis, where you'd see a network adapter, ports, network device functions. There might be a manager down here that also has an Ethernet interface, network device protocols that would, all of that would supplement where you see these things in fabric. So those are additional points where you'd see some fabric connectivity into that physical connectivity that would supplement those endpoints and switches and ports that I just talked about. Okay, so if we switch context a little bit, some of the other things that you've heard about today in terms of, you know, how does all of the storage stuff plug into some of these higher level use cases? So let's talk about composability for a little bit, right? We have this notion of this example, right? So we have memory and storage resource allocation for container provisioning. So you have these, containers over here on the left. And they would be coming in through this high level system, right? So this is similar to that picture that Mike showed you earlier. You have in this large scale system, all sorts of composability layers coming in and plugging in through, say, this OFMF services layer, coming in through RESTful APIs. You have Redfish APIs, you have Fabric clients over here, but you can also see this whole array on the right of different types of services. You have potentially CXL switches down here. So basically memory pooling and memory resources down here. So I have a memory fabric. And then up at the top here, you have storage resources. So I'm not really intending to walk through this in, rigorous detail here. The high level picture here is just to show, the storage fabrics up here, the Swordfish API and the storage are complementary to all of these other resources in the system. You may have a memory fabric, you may have a storage fabric, and then you have this services in the middle that are really focused on the fabric elements, where you have a storage fabric, a fabric specific piece that's focused on fabric allocation. You may have memory fabrics. And we're focused here talking about what Swordfish is doing, is kind of this piece up at the top looking at this NVMe and NVMe over Fabrics allocations piece. So I guess the highlight of a lot of this is that in order to put together a system, a very complex system, it kind of takes a village. We have, memory, fabrics, storage, systems management, have all of these different pieces that it's going to take to come together to deliver a big complex solution. Okay, one other thing I wanted to talk about was one of the other new pieces of functionality we had in here. Some of the new functionality we have coming in Swordfish 1.2.5, we are actually jointly delivering this, the 1.2.5 release that's coming out right now is coming out in conjunction with the Redfish 2023.1 release. So it hasn't quite been, it's been released, but hasn't been published yet because those two releases are coming out concurrently. And one of the reasons for that is because we're jointly delivering functionality between both of them in order to deliver the releases. One of the pieces of functionality we're targeting is actually around advanced NVMe and NVMe over Fabrics functionality for simplifying management. One of the things that is focused on is really this automating discovery for NVMe over Fabrics environments. The NVMe over Fabrics has had discovery controllers for a while, but they've had two different models. So they've had they're adding this notion of centralized and focusing more on this notion of centralized discovery controllers, because they need a notion of basically simplifying how to get the discovery controllers to work together a little bit more coherently, which is what's really described in this picture on the right. The existing discovery controllers basically require a lot more manual configuration. So the new centralized discovery controller model, the NVMe over Fabrics environments really cooperate. And from a client perspective, this is a really good thing, right? What we can do here is through the Swordfish API, we can really further abstract this from the storage clients. And so the clients then don't need to see the fine-grained details. What we can do is all of these NVMe aware devices, whether they're hosts or the storage devices, and, in this example, it's basically treat every single thing in here as the NVMe devices and not the clients themselves or the users themselves. All of these devices then can participate in that NVMe over Fabrics environment to develop, to participate with that centralized discovery controller functionality and present that information back. So the clients don't need to actually configure the discovery information at all. They only need to see the relationships. So that's the information then that on the management level, all we have to do is basically present this really high level information that says, I can see the discovery controller information. I can see the discovery controller, and then also from the discovery controller perspective, which systems, conversely, which systems the discovery controller is reporting information about. And that's it. We don't have to configure it. We don't have to go crazy about, trying to do any manual configuration on it or any complex relationships with it. So this is, it's an it sounds like an oversimplification, but it's a huge advance in dealing with the discovery controllers as well. So any questions on any of this part so far?
I don't see any questions on the chat.
Okay, well, I did pretty good on sticking to my 30 minutes because I did start a little bit early. So that was my 30 minutes on this part before I was going to switch over to the demo section. Oh, actually, sorry, I have one more picture here. On the discovery controller, I was talking about the radical simplification that we came up with. I thought about showing like here was the god awful picture we had of the model before as a compare and contrast. And I started to draw it up and it got so complicated. I like, oh my God, I don't even want to spend the time to draw up this picture. But we have this radically simple picture of how discovery controllers work. And it's this simple. It's not even, it's just read only. It's like, I'm a discovery controller and down here, and then here are the subsystems that contain, here's the subsystems that I found, basically. And subsystems don't even have to have actual controllers in them. It's just here's the NVMe subsystems that I have information about. And they may or may not be actually configured, just here they are. And then conversely, subsystems say, hey, here's the subsystem that has the discovery controllers that know about me. And in this case, I only show one. But there could be multiple subsystems out there, multiple discovery controllers out there that know about them. And that's it. That's all there is to it. And all of the rest of that in that previous picture is all, all of the details of anybody sending, just all of the port information and protocol packets and all of that is all done at the NVMe level. And at the management level, nobody cares. This is all they have to care about is who knows about me and who do I know about. So very, very simple model from a client perspective. None of that load because there's like a list of 20 or 30 like protocol levels of packets and just ridiculous numbers of properties that we just absolutely don't need to expose here to get to that. Okay, and here's your standard where to find more info on all of these. I'm going to walk through a few of these sites, just as we go jumping through the go walking through some of the demos on things. All right. Let's see. All right, let's see. I'll move that one out of the way. First and foremost, you want to find out anything about Swordfish, SNIA.org/Swordfish. The new one for version 1.2.5 should be up beginning of next week. We were embargoed until the Swordfish 2023.1 could be posted, which should be posted after Friday. We will get that information posted shortly. Okay, so the next couple of things I wanted to start walking through was, and then I will see where folks want to go once I start walking through some of this stuff, is we have a lot of tools up and ready for folks to work with. Some of these, the OFA and the OpenFabrics Management Framework Work Group are leveraging as well to help build the management framework. First and foremost, if you want to see examples of a lot of stuff, there's two different places to do this. One of which is the mockup site, and if this is a little small, folks should be able to zoom in on WebEx. I apologize. I was trying to just keep everything on one thing here, so I could keep everything and just move around on here. So I will apologize for if things are a little small. I'll try and zoom in a little bit as we go, so that you can see, and then you can also use your WebEx Zoom to see a little bit better. So this site, in addition to SNIA.org, you will see on this site you can see basically variations of about 17 different configurations, including a couple of the new things, right? This one shows, I've mentioned the smart metrics. We also have the configuration of the discovery controllers. I'll show you in a minute the instantiation that I just talked about on that. We also have a couple of other, 2 or 3 other different fabric things that I'll walk through here. And then the other piece we have is I have instantiations of all of these. Let me zoom in a little bit more on these two. On the Docker Hub, and there's a explicit link over on the mockup site for all of these. 3 of these or 4 of these are brand new. I just updated all of these, but I wasn't getting much uptake on these, and then I realized I didn't have any descriptions on them, so I put descriptions on them, and now we're starting to see some downloads. But all of these are the same mockups as over here, but they're in containers running on top of the SNIA emulator. So the SNIA emulator, basically, I'll show you this in a minute. All of these basically run with, it's the same mockups, but they run as if it's a live system. So you can download in a container and then interact with it. So these have security on them. So you can, and I'm going to run against one that I've disabled security just to make it a little bit easier to use. But you can download them, run, send username, administrator, and password, or create a session and interact with them. You could create and delete using the REST API and interact against any of these in the emulator. Throw the container away, start again. So they're all of these configurations. So really nice if you want to just see, hey, I want to interact with an Ethernet attached drive, or want to look at a direct attached system, or whatever your favorite configuration is on here. Sorry, I have a tendency to scroll and okay, so just looking at one I have on my system. I've already got loaded up the system here with the that I was just showing the diagram of the discovery controllers. So if we go over here, the same configuration of the discovery controllers here, where we're showing under the service root, under storage, and multiple controllers. There's what these are in NVMe. You have different types of logical controllers. So these are modeled as, or different types. So what these are actually NVM subsystems, and in each subsystem, you can have different types of logical controllers. So these are actually just named correspondingly for that. So under each of these, so this one is the one conveniently to be able to tell, this is the one that has my discovery controller in it. So if I want to query that, we can go down through. So here's my NVM. This is says it's a NVM Fabric subsystem. It's got NQN logical identifier, and then it says it's got it's a controller. I've got an array of controllers, an array of volumes. If I query this one, it doesn't actually have any in it. We'll go into the controllers link, and I can go see I have a discovery controller. So I tell when I get down to it that it's a discovery controller because it's of type discovery. It also has an array down here that says here's my list of discovered subsystems. So that's the diagram we just saw over here. So that's, and then I can go to one of these. This is one of those subsystems. I go to these, and from this I can see what kind of controllers it has. It's got set of, it's got an IO controller. Well, it's named IO controller. Is it? Go in here and see, yes, that's actually an IO controller. Configured with cross of an endpoint, so we can go see, and it's got a volume attached to it. So I can go see this volume. This volume is a namespace. The namespaces are modeled using the volume, because the namespace in NVMe is a volume in any other type of storage device. So we go down here and we can see this volume information. We can see its capacity, the size. So we can, kind of just move around the model and see what and see the information about this one. Over here, you can kind of just see all these, as I'm doing these gets here, you can see the corresponding calls. As we've moved around, as we've kind of moved around this, because this is the emulator instance up and running. We wanted to go look at anything in the mockups. The mockups are really all just a static instance there. Some of the other things that have been added that we can look at on the fabric side, we can go look at over here as well. I can query those in Postman, or I can just query them directly on the web. Some of the other things we could look at would be some of the other pieces of fabric functionality we've added. We put in some of the other new functions that have gone in have been over in here. We've recently, like I said, we recently added some of the trying to remember where I put them. Some of the new functionality, some of the other pieces we've added have been things like, that's not the right spot, it's in connections. Fabrics. Item fabrics, it's gonna be. Oh, this one hasn't been updated yet. Okay, yeah, here we go. Like we've added in the new connection keys capabilities, and we've migrated away from and added in the capabilities and moved away from the old mapping and masking and moved functionality in here. So this is some converged capabilities. This is an NVMe over fabric specifically, but we've kind of updated the model to so that we have a converged model for fabrics, for fiber channel, and for NVMe, all in the fabrics connections model here. So this is just a nice SCSI example, which if we get NVMe over TCP would look exactly, and anything using CHAP or DCHAP would actually use exactly the same way. Okay, any questions?
I do not see any questions in the chat now.
Okay. So one of the things I can ask, folks can actually go do is if you have any questions on the differences between things like how do we do things differently in fabrics between Ethernet or RDMA, be pointing you to, this mockup versus this mockup. You can kind of see differences between them. We actually also could go look at the profiles and see, in our profiles, you can actually go see what are the different requirements for Ethernet versus RDMA.
This is still swordfishmockups.com, correct?
Yes.
Okay, I'll just paste that into chat. It's just for everyone's edification.
Yeah, this site is really quite easy to just go wander around, and it does open up a ton of tabs. But it is quite easy to just go click around in. You may have to like install a browser extension to click on the links, and have it navigate you around, but it is very easy to just kind of hyperlink your way around.
And as people can tell, this is still a very active project. Meet quite a bit.
Yeah. And if there's additional configurations folks have questions on, like you'd like to see, additional information on something else, please let us know. The telemetry mockups, this has a bunch of new content. We have a telemetry service in here, but we also have in here, we added in the new metrics. So this one has the new metrics in here that shows, the new drive metrics that are coming. We have the new NVMe metrics are in this one. So there's all sorts of functionality embedded in examples of functionality embedded in these various in the various mockups. And if you want to see, would like to interact with them more as live systems, we have all of these available in the various Docker Hub containers as well. Okay.
All good. Thank you. So if there are no other questions, we have a few minutes left. Then we can wrap up. Okay, so that wraps up the second day of the 19th Annual OpenFabrics Alliance Workshop. Thank you to all of today's speakers,